Chapter 7, Similar Polygons. Today we're going to cover Section 7.3, Day 2. And your class opener. Draw two equilateral quadrilaterals that are clearly not similar. And then number 2, draw two equiangular quadrilaterals that are clearly not similar. Quadrilateral ABC is similar to quadrilateral EFGH. So I can look at the shapes, they look pretty similar. They both have some angles and some sides marked. And number 1 wants us to find the scale factor of the small quadrilateral to the large quadrilateral. So I need to find two sides that are corresponding. So I see the 4 and the 12. And when I write down the scale factor, I'm making sure that I go in the order that they're asking, which is small to large. So the small is 4, the large is 12, and then I reduce by 4 and get the scale factor is 1 to 3. Number 2, find all missing side lengths. Okay. So finding all missing side lengths, I don't know how big AD is, so I can come up here and call this X. And over on the right, I don't know how big EF is, so I'm going to call it Y. And I'm going to just make one large proportion and solve this all at one time. So I know the scale factor of the small triangle to the large, the small quadrilateral to the large one is a scale factor of 1 to 3. And I'm going to find two missing parts. I know X in the large, is unknown, but it corresponds to 5 in the small. I don't know Y, which is a value in the small quadrilateral, but I know it corresponds to 21 in the large quadrilateral. So I'm going to solve two different proportions by looking into the same spot. So I'm going to use my scale factor of 1/3 and the 5 over X, and I'm going to cross multiply. So if I cross multiply, I get 1 times X is X, 3 times 5 is 15, and I just found that X is 15. Now when I go back to my proportions, I'm going to still use the scale factor of 1 to 3, but now instead of using the 5 over X, I'm going to actually get rid of that and use still scale factor of 1 to 3, but now I'm going to look at the Y over 12, and I'm going to cross multiply this value. So if I cross multiply here, I get 1 times 21, which is 21, equals 3 times Y, which is 3Y. Divide each side by 3, and I get that Y has a value of 7. So I can come up here and Y equals 7. Okay. Number 3, find the values of X and Y. Right, and it tells me that up in the directions here, triangle ABC, which is the large triangle, is similar to triangle ADE, which is the smaller triangle. So finding the values, first thing I want to do is get a scale factor. So I'm looking for two values, and I noticed that in the small triangle, I know that this length is 9, and in the large triangle, this corresponding side is going to be 9 plus 3, which is going to give me 12. So thinking my scale factor, small to large, is 9 in the little triangle and 12 in the large triangle, and I'm going to reduce this scale factor to 3/4. So now I'm going to set up a proportion, knowing the scale factor is 3/4, and I'm going to use this to find my missing values. So if I look, the X is in the big triangle, so that's going to be on the bottom, all the values for the big triangle, and X is going to correspond to 7 in the small triangle. Now if I look at Y, Y is missing in the small triangle, but here's where it's a little bit trickier. If here's Y in the small triangle, it's going to correspond to this value in the large triangle. Well, that length in the large triangle is Y plus 5. Now I just need to cross multiply. So cross multiplying, I'm always going to use my scale factor of 3/4, and I'll use 7 over X for one of my proportions. So if I cross multiply, I get 3 times X is 3X, is going to equal 4 times 7, which is 28. Divide each side by 3, and I get 28 thirds, and I can leave it as 28 thirds, or I could go to a mixed number. I'm just going to leave it as 28/3. Now I'm going to come back and looking at my proportion to cross multiply, instead of doing 7 over x, I'm now going to do the proportion over here, the y over y plus 5, and let's see what happens if I cross multiply that. So if I start with the 3 times y plus 5, distribute the 3, and I get 3y plus 15. Now I'm going to multiply 4 times y and get 4y. Get all the y's to the same side, so if I subtract 3y on each side, I get 15 equals y. And your closure. Explain everything you know about similar polygons, and drawing a picture might help.